Hey, you guys, we're going to launch the Keostationary orbit. We're going to get to full power takeoff, 50 meters per second. We're going to do that same yaw maneuver with D to go to the 80-degree circle on the nav ball, just like we did on the orbital flight. When we get our surface velocity to 150, we're going to throttle back to 2/3, just like we did on the orbital flight, right on the R, using the control key. One thing you got to look out for is this guy. It's going to move up and down. It's basically going to be moving north and south because it's a big, sloppy rocket. And so we'll have to put a little bit of effort into maneuvering it. So Z for full throttle, T for SAS. We'll start instability assist. As soon as we get our 80 degrees yaw, we will switch to prograde. Okay, so here we go. Spacebar, wait for 50 meters per second. Okay, start yawing, D, D, D. You can see the nose is dropping. I'm going to bring in some S to bring it up. Okay, D, D, D. And then now I'm right on 80, switch to prograde. Velocity is over 150, so I need to throttle down to the R. It's a little late, but that's not a big error. It should be okay. Now look at your nav ball. You can see the orange diamond is a little low, so I'm going to hit S to bring it up. It's kind of like pulling up on the stick in the flight simulator. And I want to bring the prograde marker so it is right on that 90-degree line. So I'm giving a lot of S right now. S, 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 S until I'm on there. And you can see the prograde's right on the 90. I'm going to let go and let it fly itself for a while. It looks like it's pretty good. You'll see it kind of oscillates. It wobbles its way back to its course. That's just how it is. It's a big, messy rocket. Over here, look at your fuel. Almost burning out our boosters. We're going to hit spacebar to jettison. And then we're going to go Z, full throttle. Notice we get a full fuel tank here on this one. And we're burning that now. M for map. Let's go look at our course. Nice flat eastward orbit. And we're going to watch our apoapsis. We want to bring this up to somewhere over 70. 75 is pretty good. So you can see still full throttle on the main stage. And we just want to get that up to about 75. And then we can hit X. It's possible on this burn that you burn out your main stage and you have to go to the second stage. So just be ready for that if it stops increasing apoapsis X. There we go. So go back. I'll go back. I'll hit M. Let's go look at what we got. You can see I still got some fuel left in the main stage. I've had this flight before where I burned this out and I had to jettison it. So just look out for that. But here I've got some left. Okay, so that's nice. So I'm going to hit M and go in here, double click the planet, and I'm going to put a maneuver node. The first move we're going to do is create a circular orbit. So add maneuver, and we're going to do just like we did before. Stretch that prograde marker out until you get a nice circular orbit. Does not have to be perfectly circular. Just get close because we're just using this as a temporary orbit we're using before we go to our geostationary big old orbit. Okay. So I got those pretty even, and that means they'll usually be pretty symmetrical numbers, 72 and 79. I could fine tune it more, but that would take more time. It's good enough. All right. Maneuver marker, click that. Look at your burn. It's a 1 minute, 16-second burn. And the node is in 37 seconds. So we actually need to fire right now. So I'm going to hit Z to start the rocket up. Now what's going to happen on this, we're going to burn down the main stage. It's going to run out of fuel. So we're going to have to switch. So be ready with the space bar right when it burns out. When we go to that next stage, we're going to have a lighter rocket. We're going to have a better thrust to weight ratio. So it'll accelerate faster and you'll see the bar will speed up. So getting ready for burnout. Spacebar. Start burning that next stage. You can see the bar drops even faster because it's a lighter rocket, has the same amount of thrust, but much less weight. So just watching the bar. Still on our maneuver SAS mode. Okay. Watch that and try to hit it right at the end, right when it zeros. Boom. Okay, 2.2, that was pretty good. Hit green. M for map, let's see what we got. 73, 75, that's really good. Notice these are jiggling. I notice it does that sometimes. If you put it back, it's something Sometimes the SAS modes can change it. Let me try prograde. Nope, still doing it, just glitchy software. Anyway, so we're in a pretty circular orbit, and what we want to do is burn, and we're going to do the first part of our Hohmann transfer. So the Hohmann transfer is a transfer from one circular orbit to another circular orbit, and what you do is you burn into an elliptical orbit, and then circularize the elliptical orbit at the new altitude. Okay, so I'm going to go over here a little bit. It doesn't really matter where you go, just go a little bit in advance so we have some time. And I'm going to click and place a maneuver node. Okay, so I've got one 4 minutes in the future. That gives me plenty of time. And what I want to do is burn prograde. And I'm going to burn until my new apoapsis is 2,863,000 meters, because that's the altitude. Okay, so you can see I lucked out. I got 2840. I'm going to alter that into its 2863. Really fine changes. 2863, there we go. All right, so that's the maneuver. And you can see what it's going to do. It's going to create a big ellipse. And what we'll do is we'll get into that ellipse, and then we'll go around to the apoapsis and circularize. All right, so I got 3 minutes left. If you ever have a maneuver that's in the future and you don't want to wait around, what you can do is click on the maneuver flight path, the dotted flight path. It'll give you the option to warp to next maneuver. And so we're going to do that. And it'll do an automatic time warp, and it'll bring you out of the time warp with enough time to get your rocket ready for your maneuver. So it's warping the time. Okay, I'm going to hit maneuver SAS. You can see I have an 18-second burn. So half of 18 is 9. So my node, I will burn at T minus 9 to make it a symmetrical burn. All right, so just waiting on the clock here. If you want to be really impatient, you can use period to accelerate time and comma to decelerate, or click on the arrows. But I don't want to make any mistakes on this, so I'm going to wait it out. Imagine there's elevator music playing right now. So looking for 9 seconds. At 9 seconds, I'm going to hit Z, and then we'll burn that bar down. Z, watch the bar. Precision is important on this one. If you're late, your apoapsis will be real high. Okay, pretty good. You can see I had 2.1 left when I hit X. Green that up. Let's see what our apoapsis is. 2833. So that's a little low, right? I wanted 2863. So what I'm going to do now is a correction burn. So I'm going to go prograde, and I'm just going to tap shift to give it a little tiny bit of thrust. And I'll hit X when I see it go up. Shift. Whoop. You can see it went to 58. And I'm just going to go shift X just really quick, as fast as I can. Shift X. 2866. That's pretty dang close. If you wanted to really mess around with this and get it perfect, you could now burn retrograde to try to get rid of those 3,000 meters. But that's going to be close enough. If you got 286 anything, you're going to be fine. All right, so now let's look at what we got. This is a big ellipse. It's not a circle. Keostationary orbit is a circle. So we got to circularize. And so the best way to circularize this is to burn at the apoapsis, okay? So I'm going to spin the entire world around here. Somebody pointed out in class you can use the arrow keys for that. I always drag my mouse, right-click drag, but it's better to use the arrow keys. Okay, put the maneuver dot right at the base of the AP point there, and click add maneuver. And then this will just be a prograde burn, and we burn enough to circularize the orbit. And you guys have learned by now, when you get a circular orbit, the A, P, and PE markers will kind of move to like 3 o'clock and 9 o'clock when you get it perfect. But it's easy to go past. You can see I went past, they switched. I'm just going to slowly bring it back and try to make these. Wow, it's really glitchy today. Yeah, this maneuver thing is a pain in the butt sometimes. Oh, I'm getting it to behave. I'm going like one mouse wheel click at a time. You know how it has little clicks when you scroll. All right, that looks pretty good. Let's see what we got. 2867, 2866. That's a bingo. All right. So our node's in an hour. Well, I don't want to wait an hour, so we're going to accelerate time. Before we do that, I should have done this earlier. Remember we were worried about running out of batteries? Well, we better deploy our solar panels. So I'm going to right click on that and extend it. And that'll start charging our batteries. And then if you go on the other side, you got another one. It's kind of hard to see in the dark. Right click, deploy. And then now you got your solar panels out. So this is nice. It means that no matter, we could stay up here for months and we'd always have power. So that's good. All right, back to the map. I'm going to set SAS to maneuver node or maneuver mode. Get that ready. Let that settle down. As soon as it settles down, I'm going to fast travel, time travel to the apoapsis maneuver node. You can see that's where we are now. So it's going to take us an hour and 19 minutes to get all the way. If you put your mouse again on the maneuver flight path, the dotted one, click warp to next maneuver. It'll time warp for us and get us out there. So once we get out there, we're just going to do a burn like we said. So 19-second burn. So we want to burn at T minus 9.5, which is half of 19. So wait that out. If you want to, I'll accelerate. I'll go period. Bring it down 20, 10, comma to go back to normal time. Looking for 9 seconds. Z, start the motor. Burn that graph down. X, stop the motor. I went a little too far. Hit X to clear that on the keyboard, or sorry, on the mouse. You can see my apoapsis a little too high, 2009-38. Over here, 2867. So I could do a correction burn, retrograde, burn, because my apoapsis is too high. If my apoapsis was too low, I would do a prograde burn. And again, I'm going to do that tiny burn again, where I just tap the shift key and hit X right away. And let's see if I can change that. You can see it makes big jumps. Oops, better click that to highlight it permanently. 2890, 2880, shift, I'm just doing shift X each time. 2869, 2863, we are in Keostationary orbit. Let's see what that looks like. I'm going to do something here. It actually helps our solar panels if we switch to what is called a normal attitude. So I'm going to click normal. Boom. And let's find the planet. Where is the planet? There's the planet. And so you can see what this does is this puts the solar panels in the same plane as the sun. Now they're not rotated very well. You got one of them is hidden over here, and the other one's exposed to the sun. So you can actually use the Q and E keys to roll your ship. And then there you go. That's really good. Now I got really good solar panels. Okay, so both my solar panels are getting all the sun. You can actually right click on the sun, on the solar panels to see how much exposure they have. Okay, so now what I want to do is I want to show you how can we prove that this is geostationary. Well, let's look at what we're over. You can't really see, it's not daytime, but I'm going to start accelerating time here so we can see the rotation of the planet. And I'm actually going to click on the, can I click on, no, I can't click on that. That was a dumb idea, sorry. But you can see the planet rotate. And then what you'll notice is the ship is rotating with the planet. And every time the planet comes around, the ship will be over the same exact spot. You don't have to do this for your assignment. I'm just showing you that it is geostationary, we say over that same part. For your screenshot, click on those two AP and PEs to light them up. You have to click on the very top, get that screenshot. Now, you don't have to do this for the assignment, but it's fun to try to bring your pilot home. So you're going to do a retrograde burn to accomplish that. And what we want to do is we want to get our periapsis around 35,000. Okay. If you go too low, it's dangerous. You'll be coming in at too sharp of an angle. If If you go too high, it'll take a long time to land. So I'm going to hit Z, retrograde, SAS, Z, start burning. You'll see the periapsis comes down really quick. Once I get under 1,000,000, I'm going to hit X and stop. And I'm going to use the shift key like I did before to kind of get it fine control on this. Okay. So I just tap shift and just a tiny bit of throttle and bring this down. I'll give it a little more, a little more. I'll wait till 100,000 and then I'll stop it with X. Okay, 100,000. And then now just the tiniest tap of shift, I want to get around 35. So 90, 80, 70, 60, 50, 40. I saw 30. There we go. So I got 39. I could try to give it a little more, but honestly, it's hard. That's a good enough altitude for periapsis. So what will happen here is your spacecraft is coming in from this great distance. It's going to pick up a lot of speed. It's going to be going really fast down there. And we will just skim the atmosphere enough to slow us down. Usually it'll take multiple times to come through. You'll lose a little bit of energy each time, and then eventually it'll settle in. I'm going to go ahead and let's go back to the map. I'm going to go ahead and jettison the main stage, spacebar. I'm going to hit T to turn off SAS. We'll just let the craft drift a little bit, and that'll be okay. And then M, what I want to do is find the point about there, and I'm going to warp there. So it'll turn the time warp up and bring us there to we're just starting to come into the atmosphere. All right. Sometimes if you encounter the atmosphere while you're warping, you can get a little bit of a glitch, and it can destroy your craft. You can see here I'm under 60,000 meters. I'm going to put this on full time warp, and you'll see what happens here. So we're coming in, we're re-entering 50,000, 40,000. You'll see it starts to slow down. Your vertical velocity slows down. And I'm going to put this back on 1x. So now we're coming in, we're getting down around 36,000. Let's go on the map and see what's going on. So if you look here, we're just starting to scrape the atmosphere. And you can see the periapsis will start to go down. Your apoapsis is also going down. So we're doing what's called aerobraking. We're using the atmosphere to decrease the energy of our orbit. We are still in an orbit, but because it touches the atmosphere, it's going to lose energy every time we come through periapsis. So let's see how we're doing. Let's go back. We can look here. You can see we had some heating now. So we're starting to burn a little bit. We do have a heat shield. Altitude's coming down. That's good. We might get captured. Sometimes you get captured on the first time through by the atmosphere. But you can see here our vertical velocity went back up. So we basically bounced off the atmosphere. And we're going to go around for another pass. So I'm going to go ahead, put it on full-time acceleration. You can see that the orbit is still shrinking because we're in the atmosphere, but our altitude is increasing. So we still have too much energy. We're going to go around one more time. What you can do, it'll only let you accelerate 4 times time when you're below 70,000 meters. So we're going to wait for it to go over 70. Once it's over 70, we can set the time acceleration really high again. So I'm going to hit M. And then what I'm going to do, I'm here now. I'm going to go click over here on my flight path, and I can say warp here. See, so what will happen is the craft will go around the orbit. Why is it accelerating? It's kind of slow. I'm going to hit escape to cancel. Why did it do that? Go back to 1x. Do it one more time. Click there, warp here. There we go. So we go around out to apoapsis, and then we're basically falling in, picking up speed, and then there we are coming back into the atmosphere. Hit M. You can see we're under 67. I'm going to accelerate time a little bit, see what happens. You don't really start getting serious heating until around 30,000 meters. So we're falling still, falling. Should start to see some heating now. When I start to see that, I'm going to hit, put us back to 1x time, real time. So we're getting hot. Let's go look at our map and see what our apoapsis is doing. Periapsis, 31, dropping slowly. Apoapsis, dropping much faster. So second aerobraking pass. Usually, you can tell if you're captured if your apoapsis gets lower than your periapsis. Basically, they switch. Then you are captured. I don't think we're quite captured yet by the atmosphere. I think we're going to bounce off one more time. So, long video. Sorry. This part is not required for the assignment. I just wanted to show you in case you wanted to learn how aerobraking works. So yeah, we're bouncing off the atmosphere. I'm going to go 4 times acceleration. We're going to bounce back up probably through 70. Let's hit M. Look at the map. So you can see there. It's come way down. It was 2.86 million. Now it's going to be under 500,000. Notice the periapsis didn't change all that much. But I think the next time through, it'll probably, we'll have a low enough amount of energy that the apoapsis will become lower than the periapsis, and then we'll stay in the atmosphere. So put it back to 1 time acceleration. I'm going to click warp here. Let it go around. It's going slow again. Let's hit map. So you can't do the really serious time acceleration until you get over 70,000. All right. So there we go. Put it back to 1x. Why is that lagging? Oh, it's because I put it on warp. I got to hit escape. Click here. Warp here. Now it'll go fast. So it's going to bring the orbit around. You don't want to wait for that whole orbit. And if you want to go crazy, you could turn the warp up even further. All right, let's see what we got. Hit M. 67, so we're in the atmosphere. I'm going to go 4x on the time warp. Let's let it speed up. And you don't really start losing energy until you get down around 30,000. Atmosphere starts to thicken up. You start to see the heating. That's when you know you're really getting slowed down. Looking for signs of heating. There we go. I'm going to go to 1x time warp. I want to make sure my chute's deployed. I'm going to hit space just in case I forgot. Also, let me zoom in here. I think in the build, did I forget? No, I have it set correctly, so we're good. Okay, anyways, so now we're burning pretty good. We're here a long time. The longer we stay here, the more energy we lose. Let's go look at the map. Apoapsis 28. Periapsis was 28. Apoapsis is coming down. And again, we need to see this come down so it's really below 70. Once this gets below 70, it means that your orbit will not bounce back out of the atmosphere and you are going to land this time through. So we're hoping for this to come down under 70,000 so I can end this video. If not, we'll have to go around one more time. So it looks good now. We're starting to fall really fast here. You can see we're well under 70,000 on our apoapsis. And you'll see that the periapsis will actually go inside the planet, which means we're definitely landing. There it is. It's going to go to 0. There we go. And so now we're bringing it home. So anyways, that's aerobraking. So what's the advantage of aerobraking? Advantage is you don't need any fuel to do this. If you can get your flight path to intersect the atmosphere at a shallow enough angle, it will slow down your spacecraft and deorbit it without using fuel. Anyways, from this point on, it would just be a normal landing, and you'll slow down enough. Your chute will deploy. That's the end of the video. Good luck. Have fun.